Okay, good evening, everyone. I hope we all have a good day. Uh, e- I just switched out to George. He'll be joining shortly. He's trying to set up. So, Mr. Bright, sorry, you can carry on. I just want to pass across the information. Mr. Bright, if you are speaking, we cannot hear you. Okay, while on that, let's just hold. Let's give like some few minutes for more people to join, and while Mr. George prepares the setup. Okay, Mr. Bright, can you hear me now? Okay. Okay, Mr. Bright, can you speak now? Okay, that's fine. Okay, so good evening, everyone. I hope we are doing fine. Please react with your favorite emoji so that I know I'm not speaking to myself. Thank you very much. Thank you very much. So, oh, thank you very much, Mark. Okay, so we have Mr. George on the call already, and I think he's ready to um, take us to the next level of knowledge of DSA. And if you've been following up on the group, you get to understand. I think from what he's been explaining so far, you get to see that it can actually get easy when it comes to this DSA. Even my head is still trying to wrap around some things, but yeah, but it's as the more you practice, the more you give it time to it, it gets easier over time. So as we go on this journey, this DSA, Mr. George will continue to deliver and be with us. So I believe we are going to get better as we go. Right? For those of us still struggling, and I know many are struggling with it. So, Mr. George, you can have the floor. Sorry, Mr. George, can you hear me? If you are speaking, you are muted. Oh. Okay. Let's let's give him a minute. Okay. So you'll be joining shortly.
Hello?
Hi, George. I think
Yeah,
we can hear you.
I hope everyone can hear me. I
Please, if you can hear react, let's confirm.
Can everyone hear me? Hello?
That's what
Yeah,
I.
I can hear you. I can hear you.
Okay, cool.
I can hear you.
Yeah,
Okay.
I had a bit of Mac issue because I'm on Hybrid Learn Arch Linux. So sometimes there's an issue with the Mac, so I have to log into GNU. GNU is another tester environment for Linux, so I have to log into GNU and fix that issue. I'm still looking into it. Maybe my Happy Learn configuration is wrong. Maybe I have to fix something somewhere. So, so bear with me. Okay, but we get started. Um, I'm actually putting all 24 months curriculum together. Um, Very soon that curriculum will be given to Samuel. I'm currently like putting it together based upon the time I have, the free time I have. I'm trying to put a strong curriculum together. Um, So today we will be looking at hashing. We'll be taking a deep dive into hashing a map. So I want to share my screen. Can everyone see my screen? Hello.
Yes, yes, we can. We can.
Okay, good, good. So today there won't be much words. I think I've already shared a lot of words with you. I've shared a lot of words. I think I've given you enough motivation. In order for you to continue, I've given you a lot of motivation. So um, it will be left for how you think about approaching it. But today is not a motivational session. Today is a consistency session. So it's more on it will be more technical today. That's just to see it. It will be more technical. So um the last time we had a conversation around time and space complexity, and we did discuss that we did discuss on series of time and space complexity. If you follow the discussion, we talk about linear, we talk a little on quadratics. I know that we didn't really go deep into it because it was more like a mindset, but I just gonna introduce a little bit of because sometimes you see stuff like this, you see stuff like this. So I'll just introduce a little bit of how stuff like this work, and then right after that we can move to the challenge question because that is the main important thing. So we already know that time complexity is the judgment of an algorithm as the input grows to infinity. So whenever you are given something like this, to understand what how this time complexity work is that, take for an instance, it is not always a case it is not always a case that you see your input and you automatically decide that it is O of n. Sometimes these algorithms, they are not really O of n. They could be O of n plus m. They could be O of n plus m. How will an O of n plus m algorithm look like? So we'll open Escala draw. So if you are given if you are given two inputs to evaluate the gains, so take for an instance you are given an input, it will get some of these concepts will not stick except we start to solve problem, and then as we discuss those problems, most often that will be the time that, yeah, it will really kick in. So if you are even on the call and you are feeling uncomfortable that you are not understanding some of the things that I'm saying, when we start to solve a lot of problems, then you will understand what we are saying. Because remember, we have like because the curriculum I'm currently doing cover from now to 2028. So We will keep saying these things until it is at the back of your mind. So do not worry if you are confused. It takes time. So it is not always in every case that you will see an input and automatically believe that the input is, is just in. So take for instance, usually when you are given double for loop, we said that if you are given a loop in a loop, if you are paying attention last week, this one not too big. I told you that whenever you are giving a loop in a loop, there is always a high chance that this will be a quadratic term complexity, but it's not always the case. And today I want to discuss condition where this may not be the case. So take for instance, in the first loop, we are evaluating up to maybe m. We have a different input that we are evaluating up to, and then in the second loop, we are moving. Let's take for instance, we have an example called, we ask list, or we want to find the total numbers in an array of n. And then in the second loop, in the second space, we want to find their index, which is m. So now what we will do in the first loop, we say we want to print everything in the first loop. Now we are moving to n, right? We are going towards n. But then in the second loop, we are not counting the numbers in the array. We are not doing that. We are evaluating against their index. So we are moving towards m. So now you see you have two things here. So in an array like this, and if you have a nested for loop, the first for loop will have to evaluate the inner loop. The inner loop will have to evaluate to a complete before the evaluation of the other for loop. So such an algorithm can be termed as O n times m, because for every time you complete m, you have to multiply that by the author, which is n. So such algorithm is n times n. I hope that makes sense. If you are not moving towards the same level of infinity, like you don't have it won't be n squared, because the place you are moving is separate. First, you are counting everything in an array. Second, now in the second loop, what you are doing, you are trying to evaluate their indices. You are trying to do something that indices, or maybe you are giving a different number to reach out to. So in a loop like this, you are moving towards m times n. It can be a little bit confusing. That's why I brought it out, because I've even seen experienced engineers, they miss out on this concept. So in a loop like this, you are usually moving towards n times n. Now, what if you have one for loop where you are moving towards n, and then you have another, but this for loop is not within this one. This for loop is like by itself. And then you come down here, you have another, but this time you are evaluating to n. So for such for loop, for such algorithm, it is usually O n plus m. That is the key difference. For one, you have terms, for the others, you have r. So I just wanted us to have a clear understanding on this. Like I said, it is confusing. You can absorb it in one time. It takes time. So give yourself a bit of time. It will digest as we go along this class. Because sometimes you will see that when we are evaluating the algorithm, when we are evaluating the term complexity, you will see me writing O n plus m. It will not always be the case I read O log n or O n squared. That will not always be the case. That will not always be the case. So I just wanted to bring this to your attention. But now we have to get down to business. So today's challenge, we're going to look at, I think a lot of people have seen this question, but usually people don't know what to learn from the question. They just like see the question and then they don't really know how to break the question down. Because as you solve harder problem, you're breaking questions or breaking problem down to a minimum blocks will be something that you will have to rely on, meaning as you are doing a lot of graph, because when we start solving graph problem, you really need that skills. You will need that skills. As we start to do DFS, breadth search, you will need to firstly take how to take huge code, break it down step by step, and then reason about it. So today we'll talk about value anagram. I will go to the neatcode.io. I told everyone to create an account here. So if you didn't create an account, you can try to create the account now. Okay, so the last time on this call we solved contain duplicates, and there was several method for it. Mine was set, and then others was maybe evaluating the size of the array. So yeah, we'll solve value anagram, and yeah, I've written code before on it, so I'll just reset it. Given two string S and T, return true if the two strings are anagram of each other, otherwise return false. So an anagram is a word that contains all the character of another word. So race car, take for an instance, race car could be an anagram. An anagram, if it is a word that you take for an instance, you have a word called race car, a word called race car, race car. I don't know why this pen, even now it's bigger. So, I don't know if I can make it more nice. Is it the opacity or the stroke? I don't even know. Let me come up. Oh, no. Let me see. Stroke. Okay. I think. Okay. IYB, you have to use it like that. I'm still learning about this pen. Sorry for that. So we have a word called race car. And what they have here again? I didn't remember. They have car race. Okay, car race. So car race. They want you to evaluate if this is an anagram. If this is only an anagram, if and only if this word, all the letters in the count of the letters in this word matches the word that is below. So for an instance, if we were to do race car and count the number of arrows, the number of words in race car, we'll say in race car we have 2 arrows. 1A. What's there? Let me try and make this thing smaller. We have arrow 2. A is like 2. So A is 2. And then C is like 2. C is 2. And then we have E. E is also 2. I mean 1. E is 1. So yeah. So this can only be classified as an anagram of this, word, if and only if it contains all the characters, and not just the character, but also the characters count that is within this word race car. So we have a C here, car race. I already see. So we have a C here, we mark it. So that is 1. We have 1. So we have another, we have A, we mark this 1 too. Double arrow, yes, this is correct. AA, yes, this one is correct. So C and C, this is correct. We have E, yeah, 1E, so this is correct. So this was an anagram of the word race car because it has all the numbers of characters in race car. So now Whenever you are dealing a problem like this, there are two major approaches that should come to your mind. Firstly, one could be, let me compare their length. That should be the first edge case you think about. Because, and what is an edge case? An edge case is a condition that makes the expression to not be truth. Like, say for instance, we had an edge case in our company this time in Rwanda where I deploy a service on Windows. I deploy a service in the virtual box, but then there was an issue because you can get Docker you can get Kukamo to work on Windows. So I use the virtual box to put the Kukamo in it. But now this is on a Windows server, so I have to make sure that when the server boot up, because in Rwanda the power will go, and my boss, he doesn't like anything relating to AWS for now. He doesn't want to put anything on AWS because AWS been burning his pocket. You know, if they ask you what make you go broke, it is EKS, AWS Kubernetes, Elasticsearch. That thing burned. So what we have was an issue where our server will go off, and then once the power come back, the service doesn't boot up. So on a Windows machine, we have to make that write a script that will boot that virtual machine out. But that virtual machine that is being booted, it should be able to be auto boot on Windows. So how do you solve such a problem? Maybe you try to use a third-party service like Nassim. So you start to think these are edge cases now. You start to do trade-off. You start to use Nassim, or you move to the service we end up going for, to cut our matter short, was always up. We have to build a script that will always put our virtual machine with the server start, but we have to use always up. The reason we were able to do as a service because we had an edge case. The edge case was that the power is not always stable in Rwanda. Rwanda has one of the best power infrastructure, no due respect, but sometimes your power go like for 2 minutes, 3 minutes, like, yeah, maybe in a month you have the power going. So when such cases come up, what do you do? So that is what they call edge case, something that will trip you off balance. You have to think about it. And always when you are solving lead code problem, your interviewer will try to evaluate how do you handle different edge cases, because your solution will work on a very small input, but can your solution work on a larger input? Can this solution you created scale? That is always the issue. So you have to think about solution that scale, and in doing so, you have to think about edge case. So usually in a coding interview, you usually come up with the first solution. Don't always think that, oh yes, this first solution is the final solution. Try and judge it in your head. I know it can be challenging when you're just getting started, but as you go forward, you will see. So my approach for this, my first approach for this is to use a hash map. That is my first approach. My first approach is, let me do it over hash map. Let me do it over hash map, and if I can do it over hash map, that would be what I would do. If I'm doing it over hash map, I will take all of these characters, put them in a hash map. What is a hash map? A hash map is a map where you have key and then you have value. That is just it. If you are ever seen a JSON is a hash map. You have keys. These keys hash to a specific values. That is what a hash map is. Yeah, we are not going to go into the complexity of it, but the beauty of a hash map is that the lookup time is usually around O of 1. O of 1 means constant time, which means you don't go through any high level computing to get data out of the hash map. That is the beauty of a hash map. But one of the complexity of hash map is that when you have to look through the hash map, it is always an issue. So keep that in mind. Hash map has its own stuff, but fast looking up O of 1 deleting is also O of 1. So yeah, because you already have the key, you just put it there. So what I would do, I want to put everyone in this hash map. So I have arrow, which is 2. I want to put A, sorry, A is 2, and then we have C. C is also 2, and then we have E. Yeah, E is 2. E is 2. No, E is 1. Sorry. So now what I want to do, I want to take this hash map that I already have, and I want to compare against the next screen. So I've already have built a hash map for race car. So now what I want to do is I want to compare it against the next screen. And in that my comparison, the first thing I will do, I compare their length match. Now I build a hash map. In that my comparison, when I see a letter in C, if I see a letter in the second screen, in this screen, if I see a letter there, I reduce the count. So take for an instance, now I'm to C. I check if the map contains a key. If the map contains a key called C, I reduce it by 1. But now, as I go, I come to A. I see that this map has a key. So now, let me start Duolingo. So let me start with the eraser. I take the eraser. I remove this. I will now take my own time and replace it by 1. And then now I come again, I see A. This time around I see A. Let me just keep everything so no one get confused. I see A. So I see a C firstly, I reduce it by 1. I see a I reduce it by 1. Now I come to R. R is this. I reduce R by 1. Now I'm meeting with an R again. I'm going to reduce it by 1. So now R is 0. I come, I see a I reduce it by, it's already 1. A is already 1. So now I will minus 1. That will give me 0. And then now I want to come to this. I want to come to C. If you are confused, you tell me. We will talk about it. I reduce it by 1. Now it's 0. I come to an E. I have only one E here. So if I subtract 1, E is already 1. If I subtract 1 from E now becomes 0. So everything that was in this hash map, in this hash map got cancelled against this one. So the new map will look like this. In the new map, you have all of these characters. Let me bring it. Let me command on so we see what's going on. So in the new map, you have R, which is 0, A is 0, and C is 0, and even E is 0. So now there is a way in Java we can check if a hash map is empty. For example, if this map was maybe if this was a map, we could just call it's empty. There's a Boolean function. It will tell if the map is empty. Now, because the map is empty, it will return true. So what this is telling us is that yes, this map is empty, and we know that if this thing returns true, then we have an anagram. So before we code this up, is there any question? Is there any question? Is there any question? Any question? That anyone confused? So because no one is confused, I will jump right into the code. So the first thing, okay. I think we have a question. Who's there? The other person said I'm totally confused. Okay. So let me go over it again. Let me remove everything. I'll take my time. This is a technical session, so if you already understand it, yeah, we'll go over it again. So you have race car. You have this word, and then you have car race. I'm coming 1 second. I will get to you. Car race. Now we want to check if these two words are anagram. Can you tell me where you are confused? Hello? Victor, can you tell me, is it Victor that is confused or who? If you are confused, please, I can see everyone on the call, so please try to tell me exactly where your confusion is so we can try to work on it. If so, I'll just review the question back. So now, an anagram is a word that contains every character. Two words, you have two words. Anagrams are two words that contain every character of each other, including the amount of time that character might have appeared. So if we have a C here and we have a C here, the number of C should be equal to the number of C in raised car. That is what we are saying. We are saying, look at this word, raised car. It's the same as car race. It is just reversing. So, but we want to know if these two words are anagram. We have to make sure that they have the same equal number of characters. It's just like asking if these two words are equal. That is what we are saying. Even I think someone said in Python, but I don't like that. That is cheating. So just use Python. In Python, you can use a simple function to check if two strings are equal. If those strings they are equal, they are automatically anagram. So what we are saying, we say we have arrow. We have two arrow here. So we say arrow is 2. A, we have A here, we have A here. So A is now 2. We have C, we have C. So C is 2. We have an E, E is 1. So we say E is 1. If we have this map, and we already this map is for this word. Let us compare the two maps. So in here we have C. C is how many? C is 2. Is someone calling my phone? So we have C. So C is 2. We have double arrow here. So arrow. Let me start from the A. From the A. Sorry. We have A. A is 2. So we put A. A is now 2. We have which one? Arrow 2. A is 2. C is 2. E is only 1. Do you see the 1 E? So E is 1. So what we are saying, this map, are these two maps equal? Are these two maps equal in count? Yes, they are equal in count. So because they are equal in count, they are anagram. And how do we find out they are anagram? If we minus 1 from here and minus 1 from, if we minus 1 from here, minus 1 from here is 1, 1 here. If we minus 1 from here, it will be 0 now here. If we minus 1 from here, we get 0. So if we was to minus this map from this map, what we have an empty map. We have an empty map. That's what we are saying. Arrow is equal to 0. A is equal to 0. C is equal to 0. And E is equal to 0. Because this map is the exact copy of this map. So if we subtract these two maps, what we get? We have 0. We have 0 to be to be the new map. Now all we need to do is ask if this new map, this our new map, is this map empty? And if it is empty, we return true. This is what we are saying. This is what we are saying. I hope this makes sense. This is what we are saying. Let's go through the code and then you will figure out what I'm doing. So what we want to do, what I want to do is I want to get a hash map. It's a map of characters, and then integer has the count. So integer, so I have map. This is equal to a new hash. Okay. So now I want to put first, this is how you get into trouble. I didn't check for the edge case. So let me check for the edge case. If these two screens, if they are not equal, I want to return false. So I want to compare their length. If they don't have the same equal length, I want to return false. Now I want to have a hash map, and then in this hash map, what I want to do is I want to put all the character of S in this hash map. So that is my first target. So attend S to a character array, I think. Yeah. So now what I will do, I will say map dot put C. And then in Java, when we are putting things into a hash map in Java, it could be 0, it could be C, or it could be 0. So in this case, what we want to do, we want to say map get. So it's possible that C already exists. So it's possible that we already have a single C in that map. So if we already have a single C, if we already have a value for C like number 1, we want to increase the count. Otherwise, we put 0. So this is how you do it in Java. So if C exists, we will put 1. If C doesn't exist, we put 0. So this is the first thing we want to do. Now what we have done here, we have so we put all the characters of S in the hash map. So that is the first thing we do. The next thing we want to do, we want to go and compare the character of S against those characters of C, or of T, I mean. So we say for character, I use C for character always, so T. Array. And then, now, first thing I want to check if the map doesn't contain, if this map contains key C. If this map doesn't contain this key, it means that this is already false. So now, what if this map contains this key? The next thing I want to do, I want to decrease the count, because I'm comparing. I don't want to use, instead of using double map, I only want to use a single map to minimize my space. So what I will do, I say map.put. Now, in here, I put C, but now I want to get the count of C minus 1. Now, if that key is already like, if map if we get the key is equal to 0, I think in Java you don't have to do this. You will just say we want to remove that key. Let's say remove C. So we have to pause and see here. We compare the length of the screen. Let me go back to our diagram so you can see clearly what I'm trying to do. Okay. Okay. I hope I didn't lose the coding session. So what I have here, what I'm trying to do here, let me try to minimize this to you so you can see. So what I'm doing here, I first compare their length. I have these two words. I compare their length. If their length is not equal, I return false. Now I have the map, the hash map, in an integer value. Now I try to put all the characters of S in the hash map. I put the character of S in the hash map. Yeah. Take for instance, this screen is S and this one is T. I've put all the character of S in the map, in this map. Now I want to check if a character, if there is a character in T, in this letter, if there is a character in this word that doesn't exist in this map, I want to return false. That is what I want to do. Now, if that character exists, I want to subtract 1 from it. So this is what I'm doing here. I'm subtracting 1 from it. Now, if there is a case I have left subtracting until it remains 0, the count for this character is now 0. I can easily remove this character from my map. I can remove this character from my map. So if I remove this character from my map, it means that for that character, it doesn't exist now in my map. Then I continue until the map becomes 0, 0, 0, the way we want the map to be. And now if the map is like totally 0, what we have, we can ask like this. We can say, is the map 0? Is the map empty? So this is the logic we are trying to apply. So let me run. As you can see, it is accepted. So is there any question? Is there any question? Is anyone confused? I can go over it. I
didn't see the output.
Okay, so let me bring this back here. Here is the output. This platform is acting cookie. Here is the output. So because these two words are the same, see for an instant, the characters, they are just scattered up, but the word is the same. You have arrow, you have arrow. You have area, another arrow. C is on this side. You have C on this side. You have C on this side. You also have C on this side. You have A here. You have A here. You even have E. You have E. These two words, they match and they are anagram. So we return truth. If we are given another word, let me see example 2. Example 2. We have Ja. We have Gem. We have J and J. We have A. We have A. But do we have M? M, does M exist on this side? No. So we return false. This is what we are saying. They have to be the same number of characters. So that is solution number 1. This is solution number 1. Typically, in an interview, this will be the intuitive solution you are able to think about. This will be the intuitive solution you are able to think about if you come across this problem. The problem with this solution is that if you take a look at this algorithm, there is a perfect case since these two screens are equal, we'll call both of them n. So the time complexity is O of n. So the time complexity, because we are using 2 for loop, we have in big O notation. If you ever did big O notation, constant doesn't stand. We have 2 for loop, which is O of n. But because we have a double for loop, this constant, we get rid of it. So now it's like O(n). Constant doesn't stand in big O notation. So this algorithm, even though we have a 2 for loop, but as we approach infinity, it will be only 1. You don't write constant in big O notation. So we remove the constant of 2. Now we have n. Now for the space, because I didn't use others who have using 2 map and compare these 2 map, because I use a single map and I did some trick, but I use a single map. I put all the characters of the first word in this map and then use this the second word to minus the character for in the map. So I only have one hash map, so that will put me at ON for space. So you see for here I'm taking off ON space, and then for here I'm taking off O of N time. Is there any question? Anyone has a question for me? Is there any question for me? If there is no question, we will move to our second solution. That will be looking at okay, I think someone has a question for me. If you use two hash map, how much space will be used? Good. So if you use two hash, what a beautiful question. So yeah, that was the question I was expecting. That's a very sound question. So if you use two hash map, now you have ON, because you have to fill the first one up, and you have ON on, you have ON. Sorry, I'm coming. 1 second. You have O of N here. So now when we multiply ON times ON, we have big O of N times N. What will we have? We will have ON squared. So there is the critical thing you need to know. If you use a two hash map, immediately you use quadratic space. It's like burning up enough memory, even though your solution will be correct, but as you approach infinity, this is not viable, right? I remember I did a horrible code review for one of my junior at the time, and that nearly led to, it nearly caused me to be sacked, because I was tired. So that thing you usually see on the internet is truth, right? You sometimes won't review all the code. So we had this instance that isn't supposed to consume a lot of AWS bill, but then when this guy wrote a C or C++ code for one of our CRR tools, and then I just go through it. I didn't really understand what he was doing, but I was just tired. But I knew that the code was solving a problem, so I just, let it go. I accepted the PR, and then after some second, after it was like, I think not some second, but some days, we started to realize that this Amazon instance burning a lot of money. And then when I went to check, others that are more senior than me, when they were checking, they realized that, who reviewed this PR? I said, George. And then they called me, and then I said, oh, I was tired. And then they said, no, if you're tired, you don't have to do it the same day. Yeah, that was a learning something. So this guy was burning a lot of resources. Like he was saving images on the server. I didn't even know. He was saving images on the server, but then since he was doing some level of encryption about the images, I didn't know that he was saving huge images on the server. And apparently maybe it was some AI that gave him that code, and then he threw it on us. So yeah. So but at the end of the day, I take accountability, because I didn't want them get rid of him because he's a junior, he just coming, he doesn't know a lot about the code base. So I took the full responsibility. I should have educated him on it, but I was tired. So if you write codes that will affect the system, you will increase sometimes the company bill, sometimes you will destroy a pod. If you haven't broken a pod here in production, then you should try and do it, because in your coding journey, you'll see that they have a perfect working pod on Kubernetes. If you're ever using Kubernetes has pod. Usually you deploy the app to the pod, and then you do some update. So yeah, most often if you don't write efficient code, you could break a pod. If possible, your code will be so horrible that it brings down a whole cluster. And then everybody are like, what's going on? And then you go to ask your senior, go to assemble, you see in the log, it's messed up. Then they call you, they say you need to go for a technical review session, and you have to go do a post-mortem. But these things are natural. You will encounter it if you work in a big firm. You see a whole lot of these things. Sometimes you make mistakes. So it's important to write efficient code. It's always good. Do not be do not be too confident with your code, because you could be writing trash. You know, you could be writing trash around here and thinking that you are actually writing good code. So always be the Linux trover of your own code. Try to go hard on yourself. Try to tell. Now we have with code review tools. Try to ask it to criticize your method, criticize your code, what type of design pattern this follow. Try to be hard on your own self. Usually your code will be accepted once you are hard on yourself. Don't be too confident to report that, oh yes, I know I have solved this problem. So the next solution we try to come up with is we try to use an alphanumeric map. What are we saying? Before we do that, if you press if you press A on your machine, if you press A, this will evaluate to I think 65. The async code. So async, American Standard for Information Exchange. American Standard for Information Exchange. Async. So the async code, the async mini async tool, the async code for whenever you press a number on your computer, if you ever did backend level engineering, you will know this. It evaluates to a number. And I think A should be 65, and then B should be I think 66, and then C should be 67, A B C D is this D, like that until you reach there. But every characters you press on your computer, they evaluate to a specific number on the keyboard. That number is then turned to hexadecimal. So that number is turned to something called hexadecimal. And then after hexadecimal, it is turned to some either depending on your system architecture. But after hexadecimal, it is turned to 32 bits. So you have 32 bits. Then that 32 bits number will be evaluated depending on your system. And those 32 bits, if we even have to go deeper, those 32 bits will be given to an RC circuit. Will be given to an RC circuit that will do switching off and on. So that is the biggest thing you need to understand in computer is it is 1 and 0. But 1 mean on, 0 mean off. That is just the truth. Because at the end of the day, we only have transistor or diodes that are switching off and on. So what we want to do, we want to have a map that we can map characters to. And then based upon our mapping, we can get a clear sense. We can get a clear sense of the character position, and then use that position as a way to create a map that we can compare against the other screen map. I know it's confusing. So we want to have a map of 26. 26. You know there are 26 letters in the alphabet, so we want to have a map for them. We want to map them out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I haven't reached 26 yet. So 1, 2, 3, 1, 2, 3. So I have one more. 19, 20, 21, 22, 23. 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4. 4 times 1, 2, 3, 4, 5, 6. So 4 times 6 will give you 24. So I want to add 2 more. Yeah. So if I add 2 more, now it becomes 26. But now, how do I know the position of A in this map? If I'm giving a character like this, let me zoom it down. If I'm giving a character like this, like A, I want to know the position of A. I mean, I want to know the position of C. Where can I put C? Obviously I can represent 67 for C in my map. So what I have to do is I have to take A and subtract A position from C position. Now if I subtract A position from C position, what do I have? I have 3. So I can go 1, 2, 3, I put this on. So it means whenever this bus is on, it means that there is a C. Yeah, I hope it makes sense. I hope it makes sense. So whenever you have this pass on, there is a C. So I have put 1 here in the C position. So it means that 1, 2, 3. Position number 3 is for C. So now whenever I encounter a C, I just minus A from A. And if it increase, I remove this and replace it with 2. So now if I see a D is 68. So I say 65. I say 68 minus, what's there? 65. 68 minus 65. A, B, C, D. 65, 66, 67. A, B, C. So A is here, B is here, C is here. So when this minus this, we have 3. We should get 4. So this is A, B, C, D. Maybe I don't know my A, B, C, D, but what we have here will be what we have here will be D. So we'll increase the count. 68. I need to bring my calculator. I'm not feeling satisfied. A is 0, 1, 2. Oh, now I get it. It's in a array format. Sorry. A counting start at 0, so we will start our count at 0. But yeah, D will be, because A, we will reference A as just 0. So if we say 65, this is 3. But 3 in an array, when we have 3 in an array, 3 is the position number 4. Remember, counting start at 0. So 3 will be the position number 4. 1, 2, 3. 0, 1, 2, 3. We are programmers. If you don't understand it, probably, yeah, you need to get cracked like a developer. I don't know why they started programming at 0. I don't know, but some article I read told me that it was because of indices. So now we see a D, we put 1 to represent it. We see a E, we do the same until we are just subtracting A to know the position of that character. Please don't be confused. Please try and stay with us. Try and stay with us. So now to our issue, to our problem. Back to our problem. We have the word this pen. Come on. We have the word race car. Race car. So what we want to do, we want to take this arrow. We want to take this arrow and place it in our map. The position of arrow, if you do, let's use a simple word. Let me just use, because I don't want to go deep, I want to use a word like A, B, C, and C, B, A. Yeah, I don't want to use race car. I don't have the patience for that long stuff, and we don't have time on our favor. Very soon, I will be out of time, so we have to go. So we have A here. We put 1, because A minus A will give us 0. Obviously, so this is the position number 0, which is 65 minus 65. People, 65 minus 65 will get 0. So we put 1 to A. We have B, which is 66 minus 65. You get 1. So 0, 1. 1 is, so B is on. We have C. We have C. So now C, in this C that we have, we got 65 minus 67. I don't know what I'm doing, but we have 67 minus 65. You have 2. So C will be on. Now we have to compare it to our next word. So if we come to this next word, we say C, this C that we have here, we say 65. Sorry, I'm getting ahead of myself. Take my own time. We have C, which is, it says C is to what? 67. 67 minus 65. 67 minus 65. 65. It's the same concept from the map, but just a little bit different. 67 minus 65, we have 2. So the position number 2, we want to remove this 1 and replace it with 0. So we want to put a 0 here. I hope it makes sense. We are doing it for the second word. Now we have B. We have this B. We want to say B is to 66. 66 minus 65 is 1. We remove this 1 that A placed here and replace it with 0. Now we are back to A. We have 65 minus 65, which is 0. So we are comparing this word with this. Imagine this word can create a perfect hash map. Now this other word, because now anagram, it is now anagram, it is destroying everything that the first word did. So this now say A is here. 65 minus 65, we replace it with 0. Now, because we have replaced it with 0, we consider the map empty. All of these other spaces are 0. So the only thing we need to do now is put 0 to all the other places. We put 0. So 0 is because we didn't use these spaces, so we put 0 there. So the idea here is that we could do a for loop and check from r equals 0 up to r less than 26. Not 26, less than 26. R plus plus. And anywhere we see, if there is at least one word in this map that is on, it means these two are not anagram. Because this guy should cancel everything this guy has to offer. Take for instance, I think I've been following Nigeria very Dagma and Bila. So anytime Bila posts something very Dagma counter it. So both of them seem to be an anagram of each other. Like whenever you have Bila saying something about bank, you have very Dagma on the other side who just come out and cancel it. And I love VDM. I don't know about Bila, right? I love VDM because he has an impact across Africa. But this is what we are saying, right? Bila businessman, and whenever he says something, very Dagma on the other hand will come and then bring a more better thing. Like some people think it's destroying very Dagma business. I mean, some people think very Dagma is destroying, VDM is destroying Bila business, and they come out, they argue these are normal things. I hope they can settle their issue. But yeah, this is the same thing we are saying. A created a hash map where in the case it put all of these characters on, and then the second anagram came and removed all of them and make the map to be completely empty. So that is the trick. It's the same as the hash map, but now we are doing it with an array. So I will code it up. All right, the code. So I want to check for the same edge case. So I want to say s or length. And then I want to return false. This is the first thing I want to do. Now what I will do, I will create an array. I will call this array count, but it's a map. It's a map. It's a map. So I will say count, and then in Java, this is how you create arrays of 26. I'm limiting the array to 26. So now I have my array. Now that I have my array, I want to move from R to the length of the screen. So I is equal to 0, and then I'm going to the length of the first screen. So I'm moving from R to S to length. And I'm doing R plus plus. Now what I will do here is I will have a count that I will use to compare. So what I want to do is S character at R. You use this to get a particular character position of a word. Maybe if you have a screen, like spacecraft. We want to get the character of this word, we use character at. So if we are getting the character, say I is 0. We want to get the character at 0, it will be S. So that is what I'm saying. So I'm getting the character at S, which is for R now I is 0. So when I minus A from it, I'm minusing A from that character. I'm taking A out of this current character. Now I'm subtracting A, because when this character evaluate, it will evaluate maybe to 65 to something on the who with the keyboard. So if it evaluate to 67, if take for example this character was B, maybe this character was B, BA, or maybe this character was B. Now B is to 66 and A is to 65. So if I minus B from A, if I minus A from B, I get the character position. So because I wrap A in screen, it will evaluate to an async code that will minus. So here what will happen, what we are doing here, we are saying if this was a B now, we are saying 66 minus 65. And we get the character position of B. So that is what we are saying. That is what we are saying. So I'll do that. And then to that particular spot, I want to increase. So now this will evaluate. You know that if we minus this, the evaluation of this will result to a number. If we say if this was B, we minus 65, we minus 66. I mean 65 or 66. What we have 65. This will be equal to 1. So in a nutshell, this array will look something like this. 1. So we are getting the 1 to the 1 position. That's what I'm trying to do here. And then when we get to that 1 position, we want to increment. We want to increment. So when we do this, it means that we want to increment C in our solution here. We were incrementing when we get there. So this is what I'm trying to do. So the next thing I want to do is I want to do the same thing for the next screen, which is T. T.character at. Now character at R, but now minus A. But now I'm decreasing. I forget my semicolon. Java gonna shout in my face. So now I'm decreasing the first I increase the count. Now if a character like that exists in T, I decrease the count. So yeah, so that is what I'm doing. Now what I can do, I go to my next loop, say int R equal 0, R less than 26, R plus plus. If count at position R, if there is anything remaining in this array that doesn't equal 0, if the total array doesn't equal 0, then what I will do for return false. If not, I want to return true. So this is the solution. As you can see, this solution is very short. Yeah. So check. So I'm confident I'll run it. And then yeah. So this is the second solution to this problem. I hope you're able to learn something. Is there any question? Any question? But with this solution, yes, we are using O of M space. I'll tell you why. Yeah. Who has a question? Yes. Yes. Emmanuel. Yes. Ask me.
Yes, thank you. I'm confused why you disconnected.
Okay. So yeah, let me go over it so you get it. Okay. So remember, let me get the eraser quickly. Come on. All right. So this is this. Okay. So I want to take this school. Okay. Yeah. And then I want us to look at these two together. That way we are able to build an understanding about it. Okay. So What I'm saying here is, now we have a word bar. We have a word A, B, and C. Now, remember when we came into A, when we see A, we minus 65 and then we increase this, and this. Do you understand this, Emmanuel?
Yes.
Okay. Now, in this word, so take for instance, this is like the screen. This is the screen S. So now we have put all of these ports on. Now in the screen T will be canceling what S has to offer. So T has a C. I have to decrement here. Yeah, I have to decrement. Because now I'm searching if the characters of T can cancel out the character of A. So as I see, T has a C and this position is on. So I'm going to decrement to make the position 0. I come again, I see T has a character called B. I'm going to decrement. I'm decrementing to make sure that this position remains 0. So I will decrement this to 0. I see a character A. I have to decrement this to 0 because of this character A. So I decrement this to 0. This is why I'm decrementing. Because I want, at the end, I want my whole map to be filled with 0. If the map is filled with 0, I can come now and evaluate. I say, if R is equal, you already notice I'm trying to look through this map. This is what I'm trying to do. And now I'm saying if there exists among these boxes, if there was any character from A that T did not cancel, if there was any character from A, from S, from this screen that T did not cancel, it means that they are not equal. So I'm checking if character come at R doesn't equal to 0, I return false. It means that everything in this map, because this is like iterating through the map. So if there exists a character, a count here that doesn't equal 0, it means that both of them are not equal. Because according to our logic, T is to cancel out every error that was incremented by S. It makes sense? Or you still have a question?
Yeah, it makes sense now. Thank you.
Don't worry. As we solve, we go. There will be a time we'll come back on some of these concepts, then we'll drill these concepts. So even if you are confused, like I said, if you are confused, there will be a time you will still have a clarifying session. So is there any other question? Is there any other question? If there is no question, then we have to move to the next challenge immediately, because I was trying to submit this. So the next challenge is the two-sum problem. Everyone should know this, but it is just a point I want to bring out about it. I know everyone probably can solve two-sum. At least most often people can solve it, because it is like the first question when Google want to evaluate how you think. That's the question they ask you. Two-sum. They just ask you a two-sum question. If you can't answer it, they know that you haven't written a code in your life. So, I want to come to the roadmap. You see, there's a lot of questions here that we have to solve. And this is like on easy. So this roadmap is no medium. This is on medium. If we can complete this roadmap successfully, it means that you are Amazon ready, but not Facebook and Google, because Amazon usually take their questions from here. So if you can complete this roadmap, it means that you are Amazon ready. I think I have a list of companies. Is it Master? Yeah, I got a list of companies that Let me check. Let me show you something here quickly. If any one of you is preparing for interview and the company is on this list, try and reach out. I will give you the famous question. So, for Facebook, okay, for Amazon, you see that most of the questions that Amazon asks, I have it, right? I have it here. So if you preparing for Amazon interview, you will see a lot of the question we solve. Here is two some. This is what I'm telling you. A lot of the questions that we will solve, they are questions asked by Amazon for the lead code 150. Now for the lead code 250, these are questions asked by Meta and Google. But Google has changed their pattern. They usually now ask questions in Google Docs. So Google has now changed their pattern. They usually ask, but it's the same. If you know the pattern, you can solve it. So this is for Google. Okay, Amazon and Microsoft. Yeah, Amazon, Microsoft, and Apple. They haven't really changed a lot of their questions yet. Yeah, Amazon, even Twitter. You should be able to break into Twitter and Uber. So go message. This company is they're tough. Over the years, as we get prepared, we will be able to break. And then Netflix should be very easy for you. Yeah. So all of these companies, Cisco, Canvas, yeah, that interview question is these are companies that ask DSA question. Even Oracle, I think Oracle too, after the 150, you should be prepared for Oracle. You should be prepared. It's like I can solve a lot of this question on this list. So when you are preparing for Oracle 2 will be applicable to you. I'm actually planning to leave Rwanda for Canada so I can prepare for Google. But that will be in the future. So the two some problem, as you saw it, Amazon can ask it. I think Google stopped asking it because everyone on the internet now knows how to solve it. Some have even memorized the solution without understanding it. So I have to plug my computer. 1 second. So what we need to do in this our case now, we will look at the two some problem. It's a very easy problem. Here is it. You are given an array. You are given an array of integers. They give you an array of integers. Let me read the question to you. They say, give you an array of integer num and an integer target. Return the index of I and J such that I and J, the index position of these two numbers, are equal to the target. What are they saying? They are saying you are given an array. They give you an array. Let me take their array. I don't have my own array. 3, 4, 5, and 6. So 3, 4, 5, 6. They give you this array. Now, what they are saying is they give you some target. What is the target in this case? 7. So they gave you some target that is equal to 7. Now they are asking you find at least two numbers in this array that add up to the target. So you check this array with a simple R, you know that, okay, let me write the index position 1, 2, and 3. You know that automatically the element that is at, let's say we call this array num. So you know that num this pen. So you automatically know that num element at position 0 plus element at position 1 is equal to our target 7. But now they are asking you, they want you to return their index. They don't want you to return the target. They want you to return their index. They want you to return 0 and 1. That's all. They don't want you to return their they don't want you to return the normal itself, but they return the target. So this is the question. The question is, find the two numbers that add to the target, and then what you want to do is return their index position. The naive way to do this will be to have double for loop. You have the first for loop, you move from R to N, you find the first number 3, and the naive solution will be to come and compare all of these numbers together. That would be like the naive solution, right? You want to compare 3 and 6, then compare 3 and 5, then compare 3 and 4 and see if they match the target. But in doing that, you will have to use a double for loop, because you want to be going over 3 and then at the same time moving towards 4 and then comparing. So you have a double for loop. Here will be J moving to N, and then you are doing your comparing. The problem with this algorithm is that my grandma runs faster than it. So as you are trying to do this to compare these two targets, as you are trying to compare these two targets, you are trying to say if num at, I don't even know how we do it, but if num at R equal num at J, then we do something. Then we say, oh, we have found the target, and then we return their index position, which will be returning. We try to return. I don't even know how to spell return. We try to return a new int position R, J, right? This is the brute force. When you are solving this problem, this is the brute force solution you will come up with. And once you come up with this brute force solution, your chances of succeeding your chances of impressing the interview already drop down to 50. They start to ask you, can you optimize it? I remember I was asked to optimize a solution for a company here in Rwanda, and I even did an interview this one time. I'm feeling confident, but I don't know, things go wrong all the time. So I have to give myself the courage that I will fail. I always think that I will fail if there's a chance I pass, it's okay. So they ask you, can you optimize? If you don't know how to optimize it, now that will be an issue. So solution number 2 is the important solution. I'm not going to code this thing out. I'll just, but usually because we are using 2 for loop, you have O of n times O of n. This will give you n times n. You have O(n) squared. This is horrible. This is horrible. So this is very horrible. You have the algorithm running in quadratic terms. I told you before that quadratic terms is like this. Whenever you have an equation like this, it is a quadratic function. So such function, if you did calculus before, it is something in high school, that's a very painful topic. We shouldn't talk about that. My friends, they didn't like it, but I enjoyed that session because I understood a lot of things. But this is a quadratic term complexity is horrible. Don't do it. So the next solution we could do, let me remove all of this one. The next solution we could do for this problem, I know a lot of people have solved do some, so I just want us to close this session quickly. So the next solution we could do, we could use a hash map. You will see that for me in interview, whenever I'm confused, I'm always thinking of hash map. Yeah. So in computer science, when you go for an interview, you have a lot of tools. If you have already prepared, you have backtracking, breadth search, bit manipulation, dynamic programming, math and geometry, sliding windows. We talk about all those things. Sliding windows, 2 pointers. You have all of these tools. Now you are on array and hashing. So array and hashing, you try to look at the problem for array and hashing. If it don't work, you change. You go to sliding windows, it don't work. You go to 2 pointer, it don't work. You go to stack and queue. It's just about drilling in your tools. And these are your tools. The roadmap I showed you was your tools. I will share with Samuel. So what we want to do, we want to have a map. We want to use something called the complementary theory or how they have other name for it, but yeah, typical example, they call it the complements. So we want to use the complement. What we want to do is we want to use a hash map, and then we want to track if the difference exists. So whenever we have a number like this, we have take for an instance, we have 3. We have the position number 3. So we want to say target. This is our target here. We want to say target 7 minus 3. And we saying 7 minus 3 is it in the hash map. Now our hash map doesn't contain anything, so we say 7 minus 3. 7 minus 3, this gives us 4. We ask, is 4 in this hash map? No, 4 is not in this our hash map. So what we do, we put 3, and then we put the index position of 3, which is 0. Now we move. We say 7 minus 4. 7 minus 4 is 3. We want to ask, is 3 in our hash map? Now 3 is in our hash map. Since 3 is in our hash map, we want to return. We know that we have found a number in our hash map that contains the difference. So if we plug 3 in here, we get 0. So we will return the index of 3, which is 0, and then we return the current index of 4, this number 4, which is 1. So we return 0, 1. But the difference theory state, if and only if you have the difference, 7 minus 3, 4, you have this difference in your hash map, then it means that you can have 2 numbers. There exists 2 numbers in this set that is equal to your target. If you have the difference in your hash map, there exists 2 numbers that you can add that will give you your target. That is what the complementary theory states. So because if you check here, we have 3 already exist, but initially we didn't have 3, so we put 3 and we put 0. But now that we have 3, we take 3, which gave us the index position 0, and then we take the index position of 4. Because we have 3, there exists 2 numbers that can be equal to 7. I hope it makes sense. Take for an instance, you have 3 plus 3. No. 3 plus 4 is equal to 7. If we carry this 4 across, we have 3 is equal to 7 minus 4. If this 3 exists, it means that if we say 4 plus 3 is also equal to 7 that we have here. So this is what we are saying. That is the complementary theory. In dynamic programming, you will see a lot of time. As we do dynamic programming trees, you see a lot of these patterns will appear. Now we are on array, you will think that the questions are random. But as we get to 2 pointers, you will start to see us reusing things. And what that will do to your brain is, in your brain, you will develop circuits, small neurons, I don't know. You will develop something that, like when I ask you to code a breakfast search, maybe there will come a time we'll start doing challenges where you will go and study a specific question and then come and explain it. That will give you the confidence to code before people. Because in an interview, you always want to code before your interviewer. So you will have these smaller circuits in your brain that if you ask me to code breakfast search, I will code it immediately because I have done it a lot of time. That's why I will code it. But for you, probably someone on this call better than me, but for you, if you haven't done a lot of time, it will stop you, you will hitch and stuff. But yes, that is how programming works. Over time, you pay. Remember when you were learning ABC, when you are learning how to add 2 numbers in your primary school, 1 plus 2 was giving you hard time. If you struggle doing this, but you did it over and over till now it is like boom 3. You know it instantly because you have, in programming we say cache, you have a lot of cache in your head for it. So there's the same thing with DSA. As you solve a lot of DSA problems, your brain becomes strong around the algorithms. To the extent when we say DFS, boom, you already know what we are talking about. You don't have to struggle on it. But as we go through, because you will be with me from now to 2028, hopefully. So a lot of these things will be in your brain. So this complementary theory will be something that comes natural to you. You won't have to think about it because you will just know it. So what I will do now, I will code it up. So the first thing I want us to realize is that if nums.length, the array can be empty. That's the first thing you should think about. The edge case is that the array can be empty. If nums.length is equal to 0, I want to return so this is the first edge case. It is possible that the array is empty. So how will you solve a target? Because what is the constraint? They tell you that they didn't tell you the array can be empty, so you have to think that the array can be empty. This will make your interviewer realize that, oh yes, this guy can think about edge cases. So the next thing I want to do is get that hash map. But in this hash map, I want to get for integer and integer. Now get the map, and then what I want to do is hash map. Okay. Now I want to go from R0 to num.length. Some people like to make it easier to say in but it doesn't really matter for now. Now what I want to do is I want to find the complementary. So I'll say com is equal to, I want to take that target minus the position of. So now what I'm taking this target minus the position of the number. So target minus this. And then I want to say if map contains key com, if it contains the complementary, I want to do something. I want to return new int. I will get the position of the complementary com, which will be, in our case, in our explaining case, we're trying to get 3 index. This is what I'm trying to do, get the index, and then the current number index is R. If it doesn't exist, I want to put it there. And then if I don't see anything, I return an empty array. Yeah. So this is the solution for the two-sum. It is a popular problem. You can check on it. It is a popular problem usually asked by Amazon. So check to make sure I didn't make any error. I run it. Boom, I get an error. Oh, I get an error. Int cannot be converted to Boolean. Don't do that. You can convert an int to a Boolean. Okay. So I forget to do the comparison. I'm not trying to compare int to Boolean. Okay. So this is the solution for this problem. So as you can see, I hope you are able to learn something new. If anyone has a question, you can go ahead and ask me. Any question? Any question? Hello? Any question? Any question? If there is no question, can I ask you people a question? Is there anyone that is confused on what we did here? Hello? Everyone is silent. Oh, this DSA thing.
Or maybe you can ask a question.
Yes, I want to ask a question. So my first question is, because we'll soon be going. So yeah, right? Why do you think that this algorithm work, or what in first, who knows the space complexity of this algorithm? There is a code. Who knows the space complexity or the time complexity? I didn't talk about that. Is there anyone they call that?
Please show the solution again.
I should show the solution.
Again. Like open the solutions tab.
The solution tab?
Sorry, your code on the right. Your code on the right. Sorry, you have not saved it, so it will not be on your solutions tab.
Oh, as you submit?
No, don't submit yet. I mistakenly said solutions tab instead of the code on your right.
Oh, okay.
It was after I said it, I remember that you have not submitted.
Yeah, I haven't.
The code on your right.
Yeah. So what is the time complexity? I mean the space.
This is O of n now. This is just one for loop.
Yes. I'm talking about the space. Actually answer the other question.
Oh, I thought you meant time. So I was answering.
Yeah. But what about the space?
Space.
The space is O of n.
Would this? Oh, I was about to say the space would be O of n, since I remember in the last example you gave, the one with the anagram, you mentioned that was O of n as well because you only used one hash map. So.
Yes. So the space is O of n. The space is O of n. And why do you think this complementary work? Can anyone answer why the complementary work?
So you can save a key and use it as a value later.
Yes, that is why the complementary work, because you can save a key and use it as a value later. Because we have the key here that when we plug it, we are checking for a value. So it is why it works. So I will submit this. Yeah, so now it's completed. You can go on LeetCode. I haven't been grinding. Let me see. I think LeetCode will have an issue with me today. Okay, so I've been skipping days. So I think I skipped 2 days in this month. So to not skip days, I will just come here, just copy this, put some solutions here in LeetCode. LeetCode, you have to hold my solution from LeetCode. So this is the question on LeetCode. You can try and solve it. Yeah, I won't hear my head trying to solve it again. So you can try and come on LeetCode and solve it, because people usually, LeetCode also has competition. I should be participating in one anytime soon. They have the contest here. They have the contest. If you are confident enough and you know a lot of patterns, you can participate in the competition. Neil Wood, the guy who was creating that, I don't know, who wanted to replace programmer at a certain point in time, but he failed miserably. He is a very good coder. Currently, he's the one rank. He's the one rank 3,600. I think okay, Muru just crossed him. So Muru just crossed him. And the funny thing, this guy, I saw his post on Reddit when he was a beginner talking about how he would cross this guy, and he put a lot of time. So, the store, if they give you Nitco coins, you can come to the store and redeem your points. So they send you these. They have the shirt. Now they have the hoodie. The hoodie is like 16,000 Nitco points. Let me see how much are there. 1,276. Yeah, I will start participating in contests. Maybe this year middle, I will start to participate in contests. I know they will beat me, but I think I'll be learning as we go along. So they have the hoodie, the cap, they have the laptop, they have the Litco hoodie. You can redeem your point. They even have the Litco big O notation book. Do not be afraid. Try and get out there and solve. If you make a mistake, it's okay. Do not be afraid of making mistakes, right? It is all part of someone follow me. Okay, I have 2 followers now. Who watch the watchman? So you can build follower on. Wow. No, I'm definitely following you back. Wow. This guy is a giant. But why you follow me? I don't even have a lot to offer. Why you follow me? I don't have a lot to offer. Maybe. Yeah. Let me see if I follow him. Yeah, I'm following him. Just following. This is another hero. Yeah. So you can Litco is like a social media for people also. You can have discussion. Yeah. So feel free to explore the community. They even have this new thing called Quest. So feel free to explore the community. They have Quest. I think they have system design. I see a lot of time people are talking about system design. You can come here and then try it out. Try testing that system design you think you have against the world best designers. I was here, but I started level 3. Yeah. There is something called monotone stack. I wasn't able to just go ahead and complete it, but I will complete it very soon. So challenge yourself. Always focus and remember, process of courses, you can do anything if you put your mind to it. You are capable of doing anything if you put your mind to it. Don't let no one tell you your skills isn't enough. You can master Java. You can be better. You can even be better than me. It's 100% possible you could be greater than me. And yeah, so that is it. I will put the code in the GitHub G's and share in the group. Any question? Yes, Samuel.
Oh. Thank you very much, Mr. George. Can you hear me?
Yes, I'm hearing you.
Okay. No question from my end. It was quite smooth and very inspiring also. I've been trying to be like consistent in trying to just do this algorithm every morning, but I think this a reminder and a wake-up call to get at it, you get. So thank you very much for this wonderful session. I really appreciate you. We I think our next session will be next Saturday again. I mean, we'll have another teacher to carry us along on DSA. So we have Mr. George by next month again. So let's ready our mind to learn. So thank you all very much. You can all, Mr. George, a very big thank you for the session. So we can all have a wonderful night rest. Good night, everyone.
And also, I will share the roadmap with you today. Yes, Daniel. Yes, thank you for being here. I will share the 24 months. It's a 24-month roadmap. I will share with you, so you can post it in the group. They will know where we are heading.
Aha, that's good. That's good. That's
Yeah.
good. Thank you very much.
Okay.
Okay. Yeah. Good night, everyone.
All right. Good night. Bye bye.
Good night. Bye.